Hello, friends. Today I had a great conversation with my longtime mentor and friend, Greg Lang, who is the co-founder of Open Relay and who are the creators of Rivet. And they are a fast-growing startup built around Web3 and the Ethereum blockchain, making it a hell of a lot easier and infinitely more scalable for developers to build on the blockchain, and just overall greatly opening up the crypto space for everybody to get involved because it's exciting as hell. Greg, like me, is a huge optimist and futurist, so he is always one of my favorite people in the world to talk to about the cutting edge philosophy and the fast approaching future. I just know this is the first of many, and I can't wait.
I can't think of many people better than yourself to have on as one of the first guests. So I'm excited here. We got a bunch we can talk about.
Absolutely. So, what kind of stuff, or how does your format usually go? Tell me a bit about
This
it.
will be one of the first, so it's honestly still kind of being formed.
Cool.
I tend to have it where I'll have the person on, kind of discuss whatever they're working on. They're obviously a good one to speak to, like the first principles of it, describe how it works, because in large part I want the podcast to be kind of a like crash course. You can learn a lot of things in robotics, tech, any kind of science really, because that's kind of what it is for myself. It's just like a free form education. So
Cool.
I tend to, definitely ask those kind of base questions first, establish the basics of that field or their topic, and then dive into more niche ones, and then onto the fun philosophical creative stuff where we can just shoot the shit and talk about cool stuff.
Fantastic. Well, I'm excited to do this. This is going to be a blast.
Mm-hmm. But yeah, I guess there's a few better than you to tackle the subject of blockchain, which obviously we talk about a good bit, but most people don't know what the hell it is or the importance of it, or where to start really. So I guess we can start there. If you want to help describe kind of just an overview of blockchain, then we can move on to the difference between Bitcoin and Ethereum, the powers of each.
Yeah. So first, a bit of background about myself, really, for the benefit of your viewers. I got into cryptocurrency and blockchain through a kind of an unusual path. I am myself not a developer or programmer by training. So I started practicing law in the Kansas City, Missouri area and I was done with law school around 2010, and ended up not really liking the lawyer's role in technology companies. So some of the companies we represented were sort of startups in technology and design in this area, and I always found myself sort of looking over the fence, wishing that it was me on the other side, and that every time I was talking to them, they weren't calling me because something wasn't going well. I just, really wanted to be involved with the upside of that business as opposed to the lawyer side of it, which is like, holy shit, we've got a disaster. What are we going to do? Call the lawyers. I wanted to be in on creating something like that. So around 2011, I started looking outside of the law industry and found a position with a company called Propylon, who did legislative software for the inside of house bit of legislatures. So basically what they would do is like, take the information that comes from the legislative process and publish it to their public websites. And Propylon had software that made that part of the process of doing their jobs. So like, instead of having to go through this discrete web publication step, they would just do the things that they needed to do to organize, like a session day during legislative session. And as a result, out would pop out updates on the website. So that was a big part of what they did. Well, over the course of that, I ended up moving to Indianapolis to work on a voting system for the Indiana legislature's House and Senate. And that was how I got to know Austin Roberts, who's my co-founder at Open Relay. And we worked really well together, and we managed to build this really amazing kind of voting system for the Indiana legislature, which they're still using today. at the time, like legislative voting systems were analog still. Like they literally had click buttons that would send through a wire to a hardwired processing board, like the votes they were making, and depending on what was preloaded into the digital punch card at the front, the votes would be tallied and they would release the result. And it was just awful. It was antediluvian technology. Like, so what we ended up putting in was an open source powered thing that was like touch screens and live results on the web. So this whole new level of transparency, which and of course powered by open source software. It was a sea change for state legislatures and voting. But over the course of that, I got to be really good friends with Austin, and we found a shared love of open source software, which for folks who don't know is software where the code is not proprietary, where the things that you build using these pieces are things you can go out and see the programming languages and the actual programs themselves in libraries online and use them for your own purposes, but also know what they're doing so that the things that you're using them for aren't hidden from the people who use them.
Yeah, that's a big thing. I definitely want to. I know we're going to talk about it a bunch in this podcast and all of our like the importance of and what it stands for.
Yeah, so that was how we got into blockchain. Like Austin had read the Ethereum white paper and forwarded it on to me, and we decided like, hey, if we're going to do something in our own business later, which we had already talked about wanting to do, it should be this.
Sorry to interrupt. So he hadn't dived into it before you then. You guys kind of both got involved in the blockchain world at the same time.
Well, he was definitely more, paying attention to what the people building it were doing before I was. I was at a level of understanding of it at the time where all I could see was like, oh, it's a way to do currency without having a centralized authority control, which I thought was neat from a legal standpoint, but I had no idea how the technology worked. Exactly. And he was sitting there thinking like, in the future, this could be the way that developers come up with new ways to provide services to people, not just in money, but in a lot of places where centralization is a barrier as opposed to an assist to innovation and to people getting what they want out of life. One of the biggest innovations of the late 2012s, right, was people started using Uber, and it was a big deal because no longer did you need a taxi dispatcher. Uber, their software did that for you. People could just go on there, tap a button, and it would route a car. And that car didn't have to work for the taxi company. It could just be regular people on either side of that exchange. And in this day and age, that the neatness of that has kind of gotten lost because there's so much politics around tech. But that's still fundamentally pretty amazing. Now, what would be more amazing is if you could have the same thing exist, but there was no need for Uber to maintain a central server. And this thing was just out there that the public could use that would match riders and drivers, and there was nobody controlling it because the hosting wasn't done by some central provider and the software was created by an open source community. Then you could have it such that the slice that Uber takes is no longer a slice that they take. You could have cheaper rides and higher pay for drivers, and it would cost less overall.
I'm already getting a bunch of questions that I would love to talk to you about. I'm trying to store them until we finish your introduction and kind of introduction of Open Relay and Rivet. Yeah, let's do that, and then we'll go back to automated cars because now I'm curious.
Absolutely.
Yeah, go ahead.
There's a lot of neat stuff there. So with Open Relay, we tried to create, taking a step back, what we're good at, what Austin and I are really good at is building systems that provide software developers with an easier path to getting their jobs done. People in the know will understand what we do as DevOps and as providing back-end APIs for complicated systems using our DevOps knowledge. But for people who don't understand what that meant, essentially, when you want to work with a blockchain, there are a lot of complicated aspects of connecting to it that we can simplify. because we know what we're doing in terms of hosting a whole bunch of servers at once and making it so that they don't break and that they're running with redundancy and that our service is high availability. So by providing our service to developers, we make the barrier to entry for programming blockchain applications go way down. Mm-hmm. So a developer who maybe just finished a JavaScript bootcamp or something like that can sign up for a Rivet account instead of spend 6 months learning how to run an Ethereum node. Mm-hmm. And then it lowers that barrier to entry so people can start building useful things on blockchain faster without having to first become experts in this like Byzantine architecture. You can sort of think of it like smartphone applications on iPhone. Like you didn't see people developing applications for BlackBerry, in part because BlackBerry didn't have an easy system for developers to get an application on there, right? There was just too much complexity to make it worth recent programming bootcamp graduates' time to delve into right out of the gate. It was just like too much more complexity.
That's something you and Austin kind of gravitated to right away when you started thinking about starting a company in the blockchain space, is to kind of always be on the end of like, we want to make it, like our focus is to make it way easier for people to just access blockchain. Like,
well, it would be neat if that was the story, and that we just gravitated right there without a second thought in our heads. But in reality, it was a lot messier than that. So we actually started off because they got the Ethereum blockchain up and running, right? And that was sort of our trigger point for let's figure out something to do on Ethereum. The year that they got it up and running was, let's look it up real fast, but I heard about it in 2017.
Okay, yeah.
So it may or may not have been prior to that. It may have been 2016 or even 2015. I'm just going to look it up real fast to make sure.
I was going to say, if you want to continue, I can look it up too. But yeah, I was listening to a podcast with Vitalik Buterin, like right before this too. Just one podcast I love is Lex Friedman's podcast, where he kind of talks about AI mostly, but he talks to a lot of researchers, and it's a really cool. Right after I finished the episode with Elon Musk.
So it looks like the initial release was July 30th of 2015. So substantially before when I first started.
Okay, that's when it actually
into using it. Yeah.
Okay.
So yeah. Anyway, we've started looking for something to build around 2017. And the first place we got started was Austin was helping out this 0x protocol, which is 0x is basically a decentralized exchange protocol where you can build relayers that use the 0x protocol to share order book liquidity.
And is 0x is it the first layer that's on top of the blockchain itself?
So the 0x contract architecture is in the layer 0, like bottom level blockchain. Like if you interact with the 0x contract, it's running on Ethereum, like not some second layer side chain.
Gotcha.
So it's sort of at the very bottom of the stack, yeah. But the way that they had it set up is they wanted people to build relayers, and relayers were the folks who actually made the 0x protocol useful, right, at first. So if you wanted to have this contract, smart contract architecture that completes orders, then you needed order books, and you needed the infrastructure to run those order books and send the orders that people were trying to fill to the 0x contract on the blockchain. And we created one of those relayers at first, but what we discovered, especially as regulation got kind of intense, was that the best way we could serve with our expertise was not trying to build some kind of front end where people could go click and trade, but to provide a back end where people who really wanted to build a 0x relayer but didn't have the expertise to stand up the infrastructure to power it, they could use our service like a backend API, right? And that was sort of the innovation that sparked, or sort of our business innovation that sparked our approach with Rivet, which, we got to Rivet basically trying to build out the infrastructure for Open Relay. So, so with Open Relay, we had operationalized everything perfectly except for the Ethereum nodes, which were like really kind of a pain in the ass to operationalize. So we created an open source project called the EtherCattle Initiative to operationalize the the running of Ethereum nodes on a cloud service. So when we were done building it and we had the appropriate level of capacity for well, to ensure that it was always going to be available, we needed to run so much capacity in this system that we created. We had so much capacity that we didn't know what to do with all of it. Like Open Relay, the order book needed like 34 requests per second maximum. And the service we ended up building had a baseline availability of like 3,000 requests per second. So we had all this extra capacity. And so we started selling it. And that's sort of what Rivet does, is give you a backend API to stable, highly available node infrastructure.
Okay.
And as it turns out, that ended up being more of a popular market than what we're building with Open Relay. So that's where our focus has been since then.
So yeah, is that the way you classify Rivet? Is kind of like obviously Open Relay is the company itself. Rivet is the main product, or like the main service that Open Relay provides. Is there any separation, I guess? Like, can you use Open Relay other than Rivet?
We actually built the necessary front end infrastructure for people. Like the front end website for Rivet is at rivet.cloud, and people can actually go there and with an email, or now with a Web3 address, and sign up for an account and use Rivet without us setting you up. Now with Open Relay, we just have documentation up, and we cover the cost to ourselves with fees that our front end will or that our back end will charge every time an order gets processed using the order book. So we don't actually have a way for you to sign up to Open Relay other than to just start using it. But with Rivet, it's a separate service, and you can actually go to the site and sign up and like get metrics on your usage and add a credit card, all the traditional things people do with cloud services.
Okay, cool.
We designed it to run as much like AWS as we could, so that it was familiar to people.
And that's Amazon Web Services, yeah.
Yep.
Yeah, I'm trying to break down as many as I can if someone doesn't know some of these acronyms or just any of these basic.
Oh yeah. Well, I mean, and it's a way to simplify it is to think like, if you know enough to know what an API is, then you know that that's a way that your front end application can access some, like your web interface can access some information or some capability that you didn't yourself program, right? And what we're essentially offering is blockchain access as a service. So if you want to use information from the blockchain or send anything other than the API spec to interact with it. And we have documentation for that, and we're going to be adding tutorials for that soon. So people who just know how to build an interface that interacts and does something, we'll be able to start using blockchain right away without having to understand its intricacies.
That's awesome. Yeah, so that's the real power of what you guys are doing.
Yeah, and that was sort of the point. It's like the biggest barrier to entry is this sort of expertise required to understand how to use it. And if we can lower that barrier to entry, then we can make adoption happen faster and get more people value out of it sooner. So, and that's always been sort of our idea, is to make it so developers don't have to go it alone, so that they've got somebody who knows what they're doing backing them up on the hardest parts.
Exactly. Anybody who wants to create can actually do so without that biggest barrier.
Yep, absolutely.
So now that we have that beauty of what Open Relay and Rivet are, could you go further into and kind of explain just what, even like just in theoretical terms, like what blockchain technology is, what like why someone would want to use blockchain, what it's good for, what it really does, what it represents?
Yeah, sure. And I think the easiest way to start is to start with like just the basic, very, very first example, which is Bitcoin. And with Bitcoin, what they created there was a way for people to have accounts with money in them. That so the way that the traditional banking system works, right, is a bank will keep a ledger of how much money you have in your account. And let's say, Blago has $50 and Greg has $0 with this bank. And you go to my bank and say, like, Greg has $50 and Blago has $0 at this bank. So because I don't have an account at your bank and you don't have an account at mine, right? So if you want to send me $50, what it looks like in whatever interface we use, whether you write me a check and hand it to me, or you send it to me via Cash App, is bank number one has to figure out, okay, does Blago have enough money to send to Greg? Yes, he does. Okay, so let's go ahead and submit this transaction over to bank number two. Now bank number two goes, well, do we really know for sure if Blago has this $50 that he wants to pay Greg? And so they go through this huge, difficult process of reconciliation, where at the end of every day they true up their separate, independently controlled ledgers to make sure that that this bank can afford to transmit $50 over here to my bank, right? Because they just have to make sure that your account has what they say it does, and over here they have to make sure that that money is transmitted and applied to mine, and then they have to communicate back and forth so that everybody knows on both sides of that Blago sent $50 from his account over here at Bank A, and it's been properly applied to Greg's account over here at Bank B, so that when I spend from my account, that money can be properly accounted for, and I'm not going to be double spending money that didn't get properly accounted for. That, like, if you send me a hot check, for example, how does Bank A learn about that from Bank B? How do we know that when I deposit a check that says $50 on it, that your account had $50 in it? That's the process of reconciliation. And that used to be what basically bankers do all day. Like, that's their purpose, is to make sure that these accounts true up. And that process was highly centralized, right? You need experts and accountants over here talking to experts and accountants over there through a process that's mediated by a lot of weird Byzantine infrastructure. All this stuff has to happen. What the outside effect of that is one, the banking system's not transparent. People don't know how their money moves around. I mean, there are actually two different kinds of money. Most people don't know that. The stuff that gets sent between banks and the stuff that shows up in your account, two different things, two different kinds of dollars. So when you have, when you have a bank sending money to another bank on your behalf, they're sending type 1 of money, and then
that just like
deducting your.
When you say like they're literally different types, is that like one is just like a ledger, like stand-in value that's only like in computers that they're sending back and forth, or is there literally?
Well, actually, it's and there's a great podcast on this that I can. It's actually more of an informative like monologue than it is a podcast, not with a guest or anything, but essentially they have reserve dollars and then they have commercial dollars.
Okay.
And the reserve generally at the end of the day has to match within a certain margin of error the commercial side dollars. So when banks transact together, they use reserve dollars. And when they transact with customers, they convert essentially reserve dollars into commercial dollars.
Mm-hmm.
So,
okay. I didn't know there was a different, literally a different name.
So for every $50 of reserve, they have to have $50 of commercial to match it, roughly, with some area for fudging, because the system's complex and the rules aren't exactly clear, even to me, who's looked into this a little bit. But essentially, thanks to all of this, it takes time. Like, have you ever wondered why, like, there's a 5-day hold on transactions of a certain type? Whereas there's a 3-day hold on transactions of another type, and sometimes they can give you money instantly, and sometimes they can't, and all these rules. Nobody really understands why that is, but they're artifacts of the cost that gets added to reconcile different types of transactions, right? So if they're doing all this complex stuff, the more complex the transaction is. And when you look at international transactions, you know, forget about it. Like, I don't even know how to map one of those unless you gave me the specific transaction and let me ask very specific questions of all the banks that it has to stop at on the way. You know, like if you send $50 from New York and it has to end up in Shanghai, you know, the number of intermediaries it has to go through before it gets there is like, it's insane.
Yeah.
Right. So what you end up with is a very high cost, low speed financial system because of it. And that's what we have today. And what Bitcoin was designed to do was take out the middleman and make it so that all of the banks, regardless of who they were, and in Bitcoin, you're your own bank, essentially. Everybody's their own bank. You know, the way that it works is instantaneous, and the settlement happens all at once because they all share one ledger. Instead of each bank, each person who's on Bitcoin keeping their own private version of a ledger that they true up to everybody else's, everybody uses the same one. And that's what the magic of the technology does, is it makes a transaction ledger that everybody can trust is the only record or the only transaction ledger of record, and that it's valid and that it matches. That's what blockchains are designed to do, to build a single spreadsheet that's distributed across all the people who use it. And we can all still trust that it says the same thing as everybody else's, and that we can trust that is the correct thing it should say.
And they all hold all of it at all times, like each of those nodes?
Yeah, the nodes actually do. Before you can run any blockchain node, I mean, depending on the type of node it is, you can truncate certain information to make it less expensive to store. But they all, when it comes down to it, depend on a record that's decentralized, that everybody can still trust is the accurate record. So now if you get into Ethereum, which is what we work on, that system gets a little bit more complicated. It still works the same way. It's still all about a ledger of transactions, but in Ethereum, those transactions can be computations. They can be complex programs that run. So instead of just like Bob sent Alice 50 Bitcoin and Alice received 50 Bitcoin, so we deduct 50 from over here and add 50 over here in this account. You can have situations that are more like, you know, Bob sent an instruction to run a program stored at this account address. This account address executed the following steps, and the result was Bob and Alice each received an even split of the money he sent to the first smart contract, right? It allows for programming of transactions. Right.
So yeah, so the network itself is is it just the, because I guess there's a computational power element too. But so like in Ethereum, it's not just like Bitcoin where the network itself is literally just a running list of everything that's happened spread across all the nodes. In Ethereum, there's the added component of like the computing power that makes it happen, or?
Well, it's actually, it's still a running list of everything that happened. It's just the things that can happen are of a wider variety of things, right? It's like the possible things that you can put into a transaction are of a wider diversity in Ethereum, right? So you can have transactions to automation that result in other transactions being added, you know, and you can chain them all together in these complex steps, such that you know, you could have an address that in Bitcoin could only be another person who owns an account that receives and sends explicitly amounts of Bitcoin. With Ethereum, you can have smart contracts that do things like, if I send a call to this address and I send it the appropriate amount of Ether, then out comes, you know, some other type of token I've created and sends it to an address that's, you know, that it's designed to, that maybe even the original sender didn't intend for it to go to. You know, like they just knew that it was going to do something, but they didn't necessarily know what. I mean, that's actually a really dumb example. Nobody really does that, but it's sort of like a way to say that programs can own account addresses in Ethereum, and those programs can be run as part of the record of things that happen.
Gotcha.
So it's like, it could also be thought of as like the world's slowest computer, um, where like everything that it does is public and everybody can run programs on it. There's another way to think about it.
So when you say slowest, in what way do you mean that, in terms of, is that something that can change? Like, is it literally running slow and that's something we're trying to fix? Or you're saying that it's just because it's decentralized and shared, it's kind of like
Right. I mean, with a computer that is on your desktop, right? Like you can have, thousands of operations per second, and, not run out of processing power to do even more, right? With Ethereum, the network is only going to be as fast as the slowest computer that's part of it, right? Because to have a valid block to be dispersed, it has to send everything that happens out to every node in the network, right? So that can take a while, and until the last.
In that part, what a block is, and like what go into what a block is more so. Like,
okay. And
that process of dispersion.
Sure, yeah. I'll try to keep this like as simple as I can.
Yeah, exactly. Let me know if
So if you think of a transaction, right, as a thing that's discrete in and of itself, like Bob sends Alice 50 Ether, or Greg sends Blago 20 Ether, or whatever, then you might be tempted to think that gets recorded in a single entry on the blockchain, right? Not the case. What actually happens is that miners who are incentivized to build blocks will take those transactions out of something called a mempool, which is just like a pool of transactions that people have submitted that are possible.
Gotcha. Aren't
right?
The actual blockchain itself.
Right. And they add those into blocks that they then try to validate. So, at its simplest, a block is a list of transactions coupled with some other data necessary to make it valid in terms of the requirements of the protocol. So like, if you say the requirements of the protocol, what does that mean? Like, what's a properly addressed letter look like in the US Postal Service? You have to have a stamp. It has to be the appropriate amount. You have to put the to address in the center, and you should put a return address in the upper left. And, that's how mail should be addressed. That matches the protocol for sending via US mail. So a block that matches the protocol just contains the appropriate information necessary to be a potentially valid block, right?
Keep it secure and
just like you can't send it a GIF of me waving my hands in the air and have the blockchain understand it as valid, right? That's not a valid block. That's a GIF of Greg being an idiot. So it's really just a standard that the data has to meet.
Can that ever happen where we can send, like right now, is it only, can we potentially send GIFs into the blockchain along with the valid things?
There's a payload for data, but after a while it gets really, really, really tedious. Like, so each block has a limited number of pieces of information you can fit into it. And if you wanted to send a complex animated GIF,
just right, you thought about the fact that there's like a limit to how data rich the submission can basically be, and if there's benefit in like later if we create
each block has a maximum size that's allowed.
So
if you wanted to build a GIF into the blockchain, you could, but it would take multiple blocks.
Right? So is there ever
you could
is that something we're trying to improve on? Like, is there any kind of benefit to raising that size that's allowed, or does it not matter?
Well, there are benefits and drawbacks, right? These are all balanced against the purpose of the blockchain, which is to decentralize things, right? Like that net value of decentralizing and not having any one party control everything is kind of part of a big vision for a larger thing that we can call Web3. Sort of this idea that we ought not have three overlords of the internet controlling all the data and all the web pages. There shouldn't be a place where the government should be able to send an order and shut down half the freaking internet. Like, that shouldn't happen.
Mhm.
Right now, that's what we have, right? A court order sent to one company can take down the biggest social media platform on earth,
Mhm.
right? And a similar order sent to another company could take down almost all of e-commerce, right? Like, that's a danger if what you believe in is a free and open public internet.
Mhm.
And blockchain is just one of the technologies that you can use to open that up and take that central authority away from some powerful player that could also be beholden to the whims of totalitarian dictators or
Even just
national security
collapse.
threats.
Like, even if something like just like the threat of collapse, like let's say like the US, a meteor hits the US and blows up, like the US is just gone. Like that way
Right.
the rest of the world's commerce isn't messed up in terms of like the running like internet system. Like, it's still online. It wouldn't be offline if something like that were to happen. If we built
Well, I mean, we still have, there's still some
destroyed.
redundancy built into the centralized architecture, right?
What is redundancy? Like, I like vaguely know in context what it means, but I don't know the actual.
Right. The idea behind redundancy is like, if a meteor hits New York and takes out a data center, does that data center have a backup copy?
Yeah. Actually, yeah.
Right.
Recently, I thought when I literally watched the podcast on like Tesla updates, and he was talking about how like the new chip, there's like, just for redundancy, there's two like central chips that are the ones that process all of the automation of the vehicle, and like you could put a bullet through one and the car would still work completely fine because even it was not even maxed out yet, which is super cool.
Yeah.
Anyway, back to
Right, but the risk that the blockchain addresses is more of a human risk, right? A meteor could take out one Amazon data center and the AWS might still be running, right? Most people's web pages would be maybe a bit slower, but intact. The internet wouldn't shut off. But what if Jeff Bezos receives a court order from the U.S. Justice Department that says you will turn off all websites that have to do with Donald Trump isn't the real president and the election was faked. Like, do we want a system where people in power can turn off specific types of content? And right now, that's exactly what we have. I mean, you see the results of it, right? Like, you see Facebook taking down certain types of content that it doesn't like or that it thinks should not be up.
I heard yesterday that like Trump is trying to take down TikTok, like, so it doesn't exist anymore.
Right. Like what the hell? Like, didn't this whole country get founded on the notion of a free market? Like, and as it stands right now, the fact that we have all this centralization means that all it takes is the right court order to the right person or the right executive order to the right agency, and men's guns go stop the people from they're running the centralized service from running it in the way that they want, in the way that people want, right? But if and you saw it back when, like, after Napster went down, back with music sharing, you saw things like BearShare and LimeWire and all these companies come up where you could download a client and there was no central server that they could send a message to shut down, right? The only alternative they had was to literally prosecute people who were downloading directly. Like, this is where we see the government showing up at your door with, you owe $500,000 to the Recording Association of America or whatever.
Yeah, I never thought about that.
Right? That would be their only option to enforce a law against a decentralized system, would be just like total draconian crackdown.
Yeah.
And when you have a system that's as valuable and as important as money, if you couple that with public-private key encryption, which is exactly what blockchain does, then they may be able to show up with their guns, but they can't compel you to give up your private key. So imagine a system where there is no higher authority over the things that you control than yourself. And that's what we built with blockchains. So that's sort of the beauty of having all of this decentralized. We may we may find ourselves someday having to run our own personal intranets in order to keep things up and running. People literally installing radios on their roofs so they can connect a network with their neighbors. But it would work, and it would work without Amazon if it needed to. Now that said, that's an extreme example. Like we don't probably have that world coming to us. But the thing that's going to keep it from sliding too far is probably decentralization. So that's why we're building what we're building, and that's sort of like the whole blockchain movement. As far as storing data, though, there's technology you should check out called PFS, which is
I was going to say, you mentioned there was a couple other technologies that were like instrumental to if we want to move to decentralization overall. And I was going to ask what they were. So PFS is one?
IPFS, it stands for Interplanetary File System.
Oh, okay.
Yep. And that's a really key Web3 technology, because that makes storing data in a decentralized way easy. So you can also make references to data stored on IPFS on a blockchain and tie the two systems together very easily. So you might not store a GIF in a block, but you might point to a GIF with some data you put into a block.
So back to that area just for a little bit. Is there so is that part of what determines the speed at which a blockchain can operate? Is the like size of essentially the payload of each not transaction, but each like written part of the block? Like, could you make a faster blockchain if you only allowed like 30 character entries in each segment of the block?
That's, you would think that would be the case, but surprisingly, it's not really the case. It doesn't really have to do with the size of the blocks as to how fast your blockchain runs directly. Now, indirectly, it does influence it, right? Because, do we want to have people in their garage with a cheap, 10 years old PC able to have a node that runs on the blockchain? In a decentralized world, that's good, right? But from a performance standpoint, that just means that the whole network, before it can be in sync on a particular block, has to wait for that slowest machine on the network to be caught up.
And is it like the slowest active machine?
Right. Well, so if you're running a blockchain node, you're part of the network, right? And if you've got a really slow computer that's got a really crappy internet connection, then the network isn't technically fully caught up until you're caught up. Now, the network doesn't wait for that machine, right? Like you can't, for instance, attack blockchain by hooking up a intentionally underpowered computer to the network, right? But, when we're talking about democratizing this system, we want a blockchain that can enable as many participants as possible, right? Including that guy who has a crappy internet connection and an old computer. Like, if the blockchain can run on that, that is a more democratized blockchain than what we would otherwise have, right? So when we're talking about, what are the maximum and minimum block sizes, if we can make those smaller, then we open it up to a larger array of possible network participants, because they can have a machine that can handle it. So when we're talking about not over-speccing blockchains, we're talking about making sure that it's accessible to people with fewer resources at their disposal. So, and that's a really important part of this, because what good is a global transaction ledger if nobody in an undeveloped country can afford to use it?
Yeah, exactly. Or if it just gives you more power if you can hook up way stronger computers or chains of them.
Right.
So have that imbalance. Yeah.
Yep. So that means we have to place certain limitations on, the clients that people run, and we have to think about it from the standpoint of the least capable computing power that we can, as opposed to the most. And that will encourage decentralization and keep it from turning into just a new set of Bezoses running everything.
Mm-hmm. So then
You
oh, exactly. Yeah, that's the most, it would lose its intrinsic like value and kind of purpose if we did that.
Right.
With that limit in place, then that we never want to stop, that we always want to be going at the, like assuming the lowest level computer can still run it, so everyone's included. What are the ways to increase efficiency then that people are working on?
Right. You know, there are a lot of ways that we can do that. You know, the depth of that question goes a little bit outside of my technical reach, right? So you get into that level of thinking about it, and you start thinking about the folks who are working directly on making the next modification to the protocol.
Yeah, it's so interesting.
Right?
Yeah. So there's so many sides to it.
Right, and if Austin were on here, he could explain probably a pretty good answer to
I
that
cannot wait.
question.
Yeah, I'd love to have Austin on. I can't wait till me, you, and him can talk.
Yeah,
it'd be super cool.
But I can speak to one of those. You know, the amount of data you can fit into a single block. You know, before a blockchain can be in sync with the network, or before a node can be in sync with the whole blockchain network, rather, it has to store on its own disk some record that allows it to rebuild the whole blockchain hypothetically from itself locally, right? Like
as part of the block itself,
you have to download the whole blockchain up to the latest block in order to be caught up. And then you can be a participant actively. You can ask questions of that block, or of all the blocks in the blockchain, and get back an answer locally on your local node. So a big block size limit means that certain computers will never be able to keep up, right? So keeping that block size limit down actually makes it so more computers can viably sync a node. And that means more people can access it. So like making it so big that you could fit, you know, like an HD movie in it, basically preclude anything but somebody running on AWS from operating a node, you know? So we have to have solutions like IPFS, where we can point to a place where data can be stored in a distributed fashion. But
so blockchain couldn't work without IPFS?
I'm sorry?
So blockchain couldn't work really without IPFS? Like that's a completely complementary.
Oh, it can. It can. You know, state data is really the question. Like, and when I say state data, I mean like if you start an application that you're expecting it to know what you said to it last time. You know, like here are the files that I uploaded last time.
Personal cookies.
That's the starting state, right? So if you're going to get state data from the blockchain that includes like, here are my favorite GIFs that I starred, right? You could still store an IPFS pointer and put a starred element in that. You know, in the smart contract call you make, so that when you load the interface that calls that contract, it knows to check for blocks that have these properties to populate that list. But you don't have to have that, right? Like you can actually have totally unfile related relevant states, like each blockchain account, like each Ethereum address could have a certain number of tokens in it, right? And you don't need to store those in IPFS for them to make sense, right? You might store the graphics that represent them in IPFS if you really want to be as decentralized as possible, but you don't have to. Like you can just know the token quantities from there and have the front end of the application know which graphics to show, and those could be hosted on a centralized server. Like there are varying degrees of decentralization right now. You know, as the technology develops over time, you'll see more of that move to decentralized mediums like IPFS. But you don't have to have IPFS in order for blockchain to be useful. It just makes it more decentralized, essentially. So,
So it's not that it makes it faster because you can store smaller bits of data that point. It makes it more decentralized. What is IPFS built on? So that's not on blockchain technology. That's like a.
And this is stepping outside of my area of expertise. So you know, I can definitely point you to some people and some resources that know how IPFS works.
Yeah.
But you can think of it a lot like, you know, a decentralized file server similar to what we had for, you know, BitTorrent, right? Like BitTorrent's a really good example of a decentralized file sharing service, right?
But it's
in order
in
to,
the classic sense where it's just like a bunch of servers, not what.
yeah, it's like a bunch of computers. Like if you want to look at it the dumbest possible way, it's a bunch of computers networked together that are running software that together can emulate a data store for these files.
Mm-hmm.
So that like maybe I have a copy of a file that you want that's not on your machine, and your machine's not necessarily even connected to mine. It might be connected to somebody else running the IPFS software, but the IPFS software allows you to search for a file that's connected to the network, and it finds that file on my machine,
Mm-hmm.
right? Then it will, in the interface, show that that file is on the network. Well, you don't have to know that my machine is the one that has it.
Yeah.
But,
Yeah.
but it can find it and get it for you if the machine that has it is connected.
Gotcha.
Yeah.
Yeah, that's really interesting. I didn't even know about IPFS until today.
Yeah, and it's definitely like worth Google, because like if you just Google IPFS, then you'll find a whole bunch of neat resources about
I'm
it.
definitely gonna look into it. Yeah, and send me did you say that kind of monologue was on the IPFS or was that on something else?
I'm sorry, say that again.
A little bit ago you mentioned like a podcast, like a video of like, you said it's more of a monologue, but somebody describing, did you say that was about IPFS?
Oh, that guy. No, the guy that I was talking about the banking,
Oh,
right? The banking piece. Yeah, he's just on YouTube. But if you want to see a video service that is powered by some data that is stored in a decentralized fashion, I'm not sure if they're even using IPFS as their backend or if they're using something else. But you can check out DTube. It's d.tube.
Mm-hmm.
At that address, it's all based on decentralized storage. Like it's not centrally hosted. So,
Gotcha. Cool. So what? Now we've kind of covered what, kind of like the values of blockchain and what it does in terms of, yeah, it's basically like democratizing all the systems that there are, which at least to us is inherently beneficial because no one controls it and they kind of are always secure and exist in and of themselves, separate of any party that wants to mess with it or control it. Is there any kind of, because to me that's like an added layer, like technologies that existed or systems that existed, now we can do this better version of them where they're like democratized and safer. Is there any kind of like actual technology that is possible now because of blockchain technology, like something that couldn't have existed? Yeah, I guess a better way to put it is, yeah, there's so many systems that you can turn into something democratized, but is there some systems that couldn't have existed without being first like a democratized thing? You know what I mean? That makes sense.
Oh, absolutely. Absolutely. You know, for example, and actually this is a rough example because there are some pitfalls associated with this that when you get into the real weeds of it, you wouldn't want to do this just plainly through a blockchain.
Mm-hmm.
But there would be much more complicated problems associated with this application. Before I say it, I want to just caveat that I don't think this is a good idea, but initially it solves a key problem that gets us there, right? You know, it's not the whole problem in this particular case because of the sensitive nature of it. So voting, we vote right now by going to polling places, right? And you know, the votes are controlled from the moment they're entered into the system, and then they tabulate them, and that's how you end up with the results of elections, right? Before, you could not put that on the open internet and guarantee that that the votes were coming from valid voters, and that the ballot box wasn't being stuffed, right? Like because you can duplicate votes or duplicate anything on a traditional computing system, or you could rather, you would need something like a blockchain in order to make it so that you could have, web-based voting, where you don't have to go to a polling place. Now, that's actually not, that's still not going to solve the whole problem, and for reasons that aren't really worth getting into, because we can get way into the weeds here. But imagine any type of thing that you don't want people to be able to fraudulently make copies of. And you found a new use case for blockchains that didn't exist before digitally, right? Like, you don't want to have money where the person holding the money can go into their wallet and copy paste a whole bunch of it, right? Become their own money printer.
Yeah.
That makes the value of money pointless, right? And and before blockchains, you could do that with anything on the internet, right? There was no way to say that there's only one of these files and this is the only one that's valid. So I'm going to send you this one and I won't have it anymore, right? That doesn't happen in the digital realm unless you have a blockchain to back it up, right? So it doesn't matter if you have all of the necessary data to make it look like your blockchain wallet that you have locally has thousands of Bitcoin in it that you can send to somebody. If you can't prove it by pointing to a place on the ledger where that account has a balance, and that balance says what you have is what you say you have, right? You can't copy paste more Bitcoin into existence. So you would need something like that if you wanted to vote on a blockchain, right? Or if you wanted to vote on a computer digitally, you would need something to validate that you had your one vote and you already spent it. So anytime you've got a situation where you don't want something copy pasted.
Would the switch to that have to be done all in one step though? Like, let's say the US was to switch to a blockchain or like a cryptocurrency based voting system so that it can be securely done digitally online. Is there the problem, like, in my head, it's seeming like let's say they do that and half the people did it on like digitally on blockchain and half did it in person. How would you know that someone didn't vote in person and vote on the blockchain?
Right. And that's the dilemma, or one of the dilemmas. Like, there are lots and lots of ways where that can fall over, right? I mean,
until everyone is in the system, like, these are all the people that exist that can possibly vote.
And there's even more than that. Like, do we want a situation where there's a voting deadline of 5 p.m. on November 3rd in this particular voting district, and whether or not you have a good internet connection is going to determine whether or not you can vote on time. You would open the door to things like denial of service attacks swaying the outcome of an election. We don't want to open that kind of door either, right?
Yeah, exactly.
So if we were going to use blockchains to make elections more secure and to make tallying the results more valid, then what you would want actually is a blockchain that gets called from the polling place only, and you still have the front end check of a person who shows up, right? It's just one of those situations where technology can't be the solution entirely to a public challenge.
Exactly.
We're not at a place where that could happen yet, and arguably we won't be for some time.
Blockchain is a huge reach to get us closer to there.
Yeah, but it also does enable some really neat things that you can do today, right? Like, if people want to lower the costs for their customers for using an incentives program like frequent flyer miles, right? 1 mile does not add up to 1 mile. We all know that. Could we get closer to that? Maybe, if the cost of administering the system wasn't so high, right? We could make a mile more valuable by taking out the administrative costs. That's just one example of a place where, like, a blockchain, because you can trust the ledger, doesn't need to be micromanaged to make sure that it's accurate.
Yeah, so it's really just about efficiency of like that. Is anybody doing that yet? That's a great idea. Like, in terms of the airline one, is no one?
I think there's some research going into how that would work. There are, there's probably a blockchain project at every single company that has its own sort of like incentive bucks, whatever they might be. I would be willing to bet. And I haven't done like a news search to see if anybody said they're doing anything particular, but there's a good chance that you would find one if you Googled it.
Mm-hmm.
So to go back to the car example too from earlier, like
Yeah, let's go back to that now. Then we can head into
right, like
Elon Musk.
People are not happy with Uber, the company, right now. And the argument leveled against them, whatever your stance on it is, I personally think it's a crock myself.
The company or the answer towards them?
What the thing being leveled at the company, like the argument that they should be classifying these people as employees, and
okay, that's a crock. Okay.
But that's coming from my standpoint of like, if I were to ever drive for Uber, the only way I would do it is if I could do it on my own time whenever I wanted, and not have a boss to check to see if I wasn't even like. A lot of the reason I started my own company was to be my own boss, right? And I imagine that drives a lot of people to choose Uber over like going to get a job at the grocery store.
For sure, yeah, more and more.
Yeah, so like I don't like the idea that you're forcibly classified as an employee. No, you may not have a manager. You may not set your own schedule, says the government. Like, I think that's bullshit. But setting that aside, it would be a hell of a lot less of a problem. We wouldn't even have the debate going on if the centralized platform was gone from the equation and a decentralized series of smart contracts was essentially being Uber and allowing riders to connect with drivers, through the blockchain instead of through some companies' centralized servers.
Mm-hmm. Could that happen before cars are automated?
Yeah. Oh, yeah. You could totally get something like that up. In fact, I think there is a company that I forget the name of them that is going to be launching some kind of beta service in November. Mm-hmm. So November or October, I forget which one. But
is we're doing anything about that? Like, is there? I guess from the way I see it is, if that kind of company, if that system works, and obviously it kind of automatically displaces Uber because it's cheaper. There's not even like Uber wouldn't even want to like beat them there to do it itself because it'd still be losing money, right? But I guess
there would be no middleman to collect money. Like,
yeah.
In fact,
like if you're Uber, what do you do with this problem? I guess is the question I'm posing. Like, do you try to make this blockchain system yourself so that you still have some benefit and aren't just completely displaced? Or
you're just out of luck, man. It's game over. Yeah. When your marketplace gets decentralized.
Is anyone making a profit there other than the actual individual units?
The drivers and the riders would be the ones who would benefit directly from a financial standpoint, right? And that would be it. You might have to have a situation where
kind of fee.
Well, you could create a some kind of benefit that would be paid out as like a fee to the people who created the original application.
Yeah, because you can make like literally just like anytime anybody does a ride, just 1 cent. It costs 1 penny, and that goes to the creator.
But a more popular way to do that these days is with an open source governance token. So like recently in blockchain land, one of the bigger decentralized exchanges called Uniswap just launched a governance token to where like anybody who holds this token is allowed to vote on governance proposals for how the protocol should be managed in the future. Mm-hmm. And if I were going to build a ride sharing service that was decentralized, I would have a community-based governance approach to where, if you've got this governance token, it affords you votes, but you can also sell it for value, right? And that's sort of a way you can also reward the initial creative teams behind setting it up by giving them the opportunity to get a grant of governance tokens when they're launched. And if they rather sell off some of their voting power so they can leave it to the community, then they can cash out a little bit for what they built.
Is that dangerous in terms of like, what if one entity buys up all those tokens?
That's a worry, and that's something that you have to build into how you design your.
No, yeah, because you could have it like no one can have more than X amount.
Or you could say like on every vote, there's only you may only spend one token to represent your one vote. If you want to maximize the amount of of voting power that a person with a small amount has, you put a cap on the number of votes that one could, or what number of tokens one could commit to their vote. And that's not actually how they're done, really, because there is some of that question of do we reward proportional ownership of these government tokens with more rights, or governance tokens with more voting rights? And we do, right? There's some cases where you want somebody who's got more skin in the game to have more power about where things go, right? So it's always about finding a balance, and each protocol can be set differently so that their governance happens with some balance. But it is still a concern that somebody with some buying power could buy up single ownership of how a protocol is governed. And that's something that people have to think about when they're designing them, right? But and I can't give you a right answer for my hypothetical Uber replacer.
Yeah, exactly. Yeah.
But the creative team behind it would do well to think about it before they issued any kind of governance token, right? So
yeah, that's another really just cool thing about the space of blockchain is that more so than any other space, like you're creating like a new level of whole system. Like there's so much in like a fun way, like philosophical thought that has to go with we're creating this whole like whole system. Like let's think long term of like the problems that could come in it, because other companies and everything, they don't work in the way where after they're created and instantiated, they exist on their own.
Right.
Kind of like there's much more
There's always
control. Like this thing now exists and runs itself. So there's so much more front end. I mean, it could be considered a risk, and it can also be considered just like a really beautifully interesting puzzle kind of to get to solve and make systems. It's so cool.
Exactly. Like who's going to benefit the most from like take the Uber example, like a community proposal to require drivers to provide more identifying information so that they can be held more accountable to your trust mechanism. Like how many votes do riders and drivers get? How many votes do whoever holds the most tokens get? Like what's the fair way to do this? Is always going to be a tough question to answer. And that's because while you can program the machinery of governance, you can't expect human beings to not have some kind of influence in how things are governed. And that's why when you build these systems, you have to be careful to build in enough flexibility that the mechanisms themselves can change as people see a need to change them. It's always going to mean there's some politics, but it also means that things are going to happen more transparently and be in public. And at the very least, we know who is doing what and who's advocating for what, if they're built the right way. But there's never going to be a situation where we can automate away all of these tough questions.
Yeah.
There is a situation though that can be ameliorated, which is outside influence. People with no skin in the game, governments, for instance, like the state of California, won't be able to come in and outlaw your decentralized platform because there will be nobody to sue to take it down.
Yeah, that's so awesome.
So people will be freer to do what they want to do with their lives if you give them this power. And I think that's really the key benefit. Some of the pitfalls of it sort of fall out when you start talking about the nuances of governing via code. But do developers have disproportionate power in a system like this? And the answer is clearly yes. How you address that is another question, and you can't. It's actually recently I got to make a plug for this. Recently, we've had the good fortune to get involved with something called Prime DAO, which is a platform that is going to provide sort of a thoughtful approach towards getting decentralized finance ready for mass adoption, which will then have different working groups and folks sort of involved in the specifics of these types of questions as they relate to decentralized finance. So how do we make sure that that a decentralized system is fair when people start investing like their retirement savings in it?
So that's what this company concerns itself with. They kind of like, they're there to help guide blockchain companies through this process.
Well, more to help address from a developer's standpoint, how we create these systems in a way that is fair and equitable and does so with the right values and the right mindsets. How do we make it so that this system self-regulates in a way that never sort of dog whistles our impulse to call in governments to regulate?
Do you think blockchain, the whole like, community of it will, I might already have it, maybe I just don't know, will ever have kind of like a system in place, end up making kind of agencies that in a way kind of akin to like the research community where they have like, when you publish a paper, it has to be like peer reviewed, like before it's released so that like it's kind of verified. Like, you think some kind of system will be put into place in the blockchain community where there's some kind of peer verification of like, okay, this won't hurt people. Like this won't, like just kind of what you just said, like this, like we're another blockchain group, like we've gone through your kind of your thinking on this and like the way this will work. And we agree that there's no potential for harming people or their safety or their privacy.
Right. Community standards that have teeth.
Yeah, exactly. Yeah. Is that a thing that exists now, or do you think
that is a big part of what Prime DAO is interested in with decentralized finance, is to sort of help people come to an understanding of what that means, right? And we can't put a whole lot of teeth behind anything that doesn't get broad adoption in and among crypto projects. So the conversation has to be public and open, and we have to make sure that everybody has some consensus around what that kind of those kind of standards need to be, and whether or not they cover the full gamut of concerns. And it's always going to be a work in progress, right? But yes, the short answer to your question is yes, that is a goal that people are working towards in, especially in places like finance, where retirement savings and education savings and things like that can be implicated, and we want to make sure that people are protected in the right ways, that we don't need outside interference in order to govern it appropriately. That people can trust that this decentralized system keeps their best interests at heart, without the need for an SEC or some other regulator, some alphabet soup agency to come in and say, like, this is how it has to be. If we address the concerns up front, then there's no reason it can't be self-governed. So, and we just have to build in systems that give people the kind of trust they would have in the systems, that they feel like they can leave behind a world where bureaucrats are the people who they have to be able to trust, right? And I don't think it's a very high bar, to do better than our current financial system at being accountable to the public. But at the same time, if we want it to be incremental, then we're already there. If we want to be a sea change in the way that people think about finance, then we've got some ways to go. And I think that's where we really want to get to, is where this isn't just an evolution, it's revolutionary.
Exactly. Yeah, that's a beautiful point. It's a good thing. It's a big thing that I never thought about before in terms of the blockchain community. This was kind of a movement that was already happening. I'm glad it is.
Yeah. I'm really I'm thrilled to be a part of it, because I got into law once upon a time. To bring the conversation full circle, I realized we're 10 minutes left, but
I actually have I found out, I don't know what your time constraint is like, if you but yeah, I actually found out I was free till 1. So
okay.
You can do 12.
I actually do still need to go at 12:30 today.
That's totally okay. That's totally fine.
But next time we can do the whole 2 hours. So I think the cool thing here is, when I went into law, because I wanted to make a difference in the world. And when I got out of law, a big part of the reason I got out of it is because I realized that, I wasn't going to be able to make the kind of difference I wanted to make when I thought I was going to go into it.
Mm-hmm.
So, being in a situation where the things that I get to work on now could really do some of the things that I thought I was going to be able to do when I was practicing law has been very gratifying personally. But I think we find ourselves in a situation right now where, we can make a choice as people who are building these things in the blockchain community. We can make a choice as to whether or not we want this to be a true revolution, whether or not we really want to liberate people, and really create the vision of Web3. Like Web3 was in part a reaction to the fact that Web1 turned into this centralized Web2 monster that eats people's data and doesn't really think of them as people.
Mm-hmm.
And right now we have a choice to make, and that choice is similar to the one we made with Web1, and we made the wrong one, right? Do we want to grow as fast as possible, or do we want to make sure we do it right?
Mm-hmm.
And I think right now, to see things militating towards doing it right as opposed to doing it fast, I think that's a really good sign for where we are as a movement. So, for what that's worth. Excited to be a part of it.
No, it's an exciting thing. Like the more I learn about even a lot in this last hour and a half, the more I learn about the whole blockchain community and the whole movement itself. It's one of the most exciting and beautiful things going on right now, and that it's almost all like altruistically driven. Like in terms of, it's all about freedom essentially of people and all of their lives, their assets, like the way the technologies and systems in the world are going to work and making sure it works for everybody. It's a beautiful thing.
Right. Well, I mean, and also maintaining this notion of permissionlessness, that you shouldn't have to get a permit to do X, Y, or Z. The system could handle that up front if it was based on right technology.
Mm-hmm.
And that's sort of what this does. Like it allows people to decide to do something and not get permission first, because the misbehavior that permission is meant to prevent can be prevented up front in the way you design the system. The Rails the thing runs on doesn't go over here into evil space, so you don't need to check to see first if people are going to be evil before you let them do something.
Mm-hmm.
It's a difference between don't be evil, which is the motto Google abandoned once upon a time, and can't be evil, which is sort of something you'll hear in blockchain when you think about how protocols should be designed, right? Like we shouldn't have to worry about don't be evil. We should make it so that you can't.
Yeah, a much higher thing to strive for.
Yeah. So anyway,
well,
I'm optimistic about where we're headed. So
yeah, me too. Always optimistic. Well, I don't think we're going to find a better way to end it than that. I just want to say more so, I actually want to just thank you that I never would have been introduced to the whole world of this if not for meeting you. And much more than that, obviously, you know how much meeting you meant to me. You know how much I love you. You've been a mentor to me. You are a mentor to me, but also I'm the oldest of all my generation in terms of my family. Like they're all younger cousins, younger siblings. You're definitely the older brother I never had. And I'm excited for all the future things we're going to do and talk about.
Awesome, man. Yeah, I'm pumped. And thank you for that huge compliment. I can't, not sure if I can come up with a better way to respond to that than just saying thank you. And, I'm looking forward to working with you on different conversations and bringing other people in the conversation, and hopefully, you're reviving some of that optimism that you and I both agree people are sorely missing in this day and age, and that they have every reason to still maintain. And I think we can show that to people through what we're doing here. So.
Exactly. Me too.
Yep.
Excited about the future. Excited about it all.
Cool.
Yeah.
All right.
Perfect. All right. Well, let's talk soon. Have a killer day.
We'll catch you later, man. All right. Cheers.